Welcome to the DelftX course Solar Energy. My name is Arno Smets and I will be your lecturer for the coming 8 weeks. This course is a general introduction into the variety of technologies which harvest the energy in solar light and convert it into electricity, heat or fuels. In this first block, I would like to give you a short overview of the course. The course can be divided in 3 major parts. The first part, week 1 up to 3, covers the fundamental physical principles on which the solar energy technologies are based. The second part, week 4, 5 and 6, discusses all solar energy technologies. The third part and last part, week 7 and 8, discusses the solar energy systems. At the end, you are expected to be able to design your own solar system. The lecturers are given in short video clips of around 10 minutes, like this one. Between all video clips, you will find many exercises. In addition, we have included more general questions which can act as discussion material for the students on the course block. At the end of each of the 3 parts, we will have a short exam, which covers the material discussed in that part of the course. This means you can do an exam at the end of week 3, 6 and 8. Now I will give a more detailed overview of the course content for each week. In week 1, I will give you a general introduction into solar energy. I will discuss the variety of technologies for energy conversion we are using today for our energy needs. I will try to put the role of solar energy in perspective in reference to other energy sources. I will teach you the difference between photovoltaic and solar heat. You will be introduced to the concept of photovoltaics and its related technologies. The current status and prospects of solar energy will be discussed. In addition, I will give a quick overview of the history of solar technology. Finally, I will finish this week by discussing some important physical properties of the energy source itself, sunlight. Week 2 is the most fundamental week of the course. I will introduce you to semiconductor physics and how we use semiconductor materials in devices to directly convert solar light into electricity. Don't be afraid if physics is not your thing. I'm using many animations to explain the physical principles of semiconductor materials and photovoltaic devices. In week 3, we will discuss how we determine the performance of solar cells using the external parameters like open circuit voltage, short circuit current density, fill factor, maximum power point, and conversion efficiency. In addition, I will discuss the general design rules for solar cells. These basics you learn in the first 3 weeks form an excellent toolbox to understand the various solar technologies and solar systems we introduce in the last 5 weeks. After week 3, you will have your first small exam based on part 1. In week 4, we will discuss the most dominant solar cell technology, which is based on crystalline silicon wafers. We will discuss the processing methods, the various different device concepts, and the challenges of the crystalline silicon PV technology for the future. In week 5, we will discuss the other PV technologies based on thin films. Thin film PV technology uses less material and is produced by cheaper processing methods to further reduce the cost price of solar energy. In addition, we discuss the concentrator multi-junction solar cells, which have up to date the highest conversion efficiencies among all PV technologies. In week 6, the future generation concepts are discussed which are supposed to beat the Shockley-Quasar efficiency limit of a single junction solar cell. Secondly, I will introduce you to the solar heat and concentrated solar power technology. Finally, we will talk about the solar fuel technology. Photoelectrochemical approaches will be discussed. After week 6, we will have the second exam moment, covering weeks 4, 5 and 6. In week 7, we start to discuss the PV systems. We will introduce you to other components of PV systems, such as batteries, inverters, maximum power point trackers, charge controllers. In week 8, we will discuss the most popular system topologies, like off-grid systems and grid-connected systems. We will provide you the tools to be able to design any PV system on paper for any application. After week 8, you will have your last exam. So after this introduction, let's get started. Solar energy technology is based on the conversion of energy of light into electricity, heat and solar fuels. It means we are talking about energy conversion. We will discuss that in great detail in the next block.